The platform you can see behind me floating on the Atlantic Ocean is known as the Penguin. It can produce energy thanks to the movement of the waves. And as you're about to see in this report, its design, construction and maintenance have been full of ups and downs. With 75% of the Earth's surface covered by water, wave energy has huge potential. The Orkney Islands are something of a wave paradise. It's a logical location for installing and testing a prototype aimed at turning the motion of waves into energy.
When the wave is passing it, the hull starts rotational movement. It's an asymmetrical hull. And inside the hull there is a decentric mass which starts to follow hull movement. And on the same shaft with the decentric mass is coupled a generator which starts to rotate. So wave movement is converted to continuous rotation inside the Penguin.
The prototype, anchored to the seabed 50 meters deep, was installed in spring 2017.
We've had peak waves in the last winter of 18 meters and extended periods of 10 meters, significant wave height, and it's been fine.
Submarine cables drive the harvested energy to this station, where it's stocked and later fed into the local grid.
This site is able to cope with 7 megawatts of electricity production on site, and each cable can take up to 1 megawatt. The important thing about being able to feed electricity into the grid is that means that the developers can earn a return for any electricity that they produce during the testing period.
The whole system is controlled from labs at this local university. Fibre optics help the Penguin send data to control engineers.
It's really slow at the moment. I'll just try and catch the...
We've got probably 40 or 50 instruments that we sample very quickly, and we've also got control information, but then we receive data. We use fairly standard accelerometers. So what that does is that's telling us what the hull is doing and the accelerations and in what direction.
Researchers here see the Penguin as a game changer in a market of wave energy estimated at some 74 billion euros.
Once all these sources and all these technologies are in use, in full use, I think the whole Europe, but not only Europe, but the world is going to be a whole different place.
This is just one of a myriad of projects funded by the European Innovation Council initiative, aimed at giving a boost to the European Union's most promising innovations. According to some data, 85% of productivity growth in modern developed economies is the direct result of innovation. But European companies still spend less on research and development than other global competitors. If the share of scale-ups in Europe matched that of the United States, in 20 years it would create up to 1 million new jobs and add 2,000 billion euros to EU GDP. With that in mind, the European Innovation Council pilot has 2.7 billion euros to fund innovators and researchers to scale up their latest innovations in very different fields. And another of these innovations aimed at shaping our future is, curiously enough, inside this 30-year-old locomotive. We're in Riga, Latvia, where this old diesel locomotive has been given a new lease of life. It's been retrofitted to also run on natural gas. Researchers hope their efforts here will help keep the European railway industry on the right track of economic development. A few days are all it takes to install the 25 or so mechanical components, allowing the locomotive to switch from diesel to natural gas. Researchers say the retrofit enables a reduction of some 15 to 20% in emissions of carbon dioxide and more than 30% of nitrogen oxides, thanks to a complex network of innovative devices.
The dual gas diesel platform is made up of different components, the gas storage and gas reducing systems. We also have an electronic solution to manage diesel fuel and gas fuel supplies, and it has a telemetry platform. We should also mention the safety systems, including fire safety and the detection of any gas leaks.
Researchers say the system has been designed to allow operators to pay off their retrofit investment in about 3 years, mainly due to a reduced diesel bill.
Dual fuel technology targets critical challenges of railway industry: fuel costs and environmental issues. Fuel costs contribute up to 50% of all operational costs for railway operators. Substitution of diesel fuel with natural gas benefits in up to 40% of fuel cost savings.
Hybrid diesel-natural gas locomotives present plenty of challenges. For instance, their engines are prone to increased combustion pressures and temperatures. So engineers had to come up with sophisticated mechanical and software solutions.
The telemetry system has a dispatching function to provide an early warning in critical situations. This data will help us reduce maintenance time and improve efficiency while using other locomotives. The system also has an artificial intelligence platform designed to spot and transmit any problems in the engines that can't be identified by other means.
Existing diesel locomotives are equipped with inefficient engines, and here in Latvia, complete electrification of the railways would require huge long-term investment. So the Latvian Railways CEO says he sees this and other technologies as a promising, cost-efficient starting point to prepare the sector for a highly competitive future.
We face stiff competition not only from road transport but also from other railway companies. So we definitely need to invest in new, innovative technology that can give us an edge and make us more competitive.
Finally, how can European power plants become more competitive? This one in Sweden uses wood chips as biomass. 100,000 tons of wood chips are used here every year to produce energy. And a highly innovative technology is currently being tested to improve efficiency and competitiveness in the sector. The power plant uses wood chips to produce energy, providing heating and hot water to the 20,000 or so inhabitants of the town of Norrtälje. Wood chips come from very different places. Some are bark chips, others are root or branch chips. The quality varies tremendously. Often their energy value is low. Sometimes they're too wet. And other times, problems are even more dramatic.
This is an example of the issues we usually face here. This is ash, remaining after the combustion of wood chips full of dirt, sand or stones. Ash from those wood chips turns into a sort of glass that can damage the functioning of our whole system. This situation forces us to carry out costly maintenance work and can even eventually lead to the interruption of our energy production, because we need to stop combustion activities to clean up the boiler.
European researchers have installed this biofuel analyzer here. 1 minute is all it takes to estimate the moisture and ash content of wood chips, their energy content, and also any presence of sand or stones. A specialist laboratory would require several days to gather this data.
It's an economic issue. You can check the quality of a biofuel and you pay for what you buy. You pay for what the truck has left for you. And there's an environmental issue. You get less emissions, less ashes if you have a higher quality of the biofuel. And then there is less maintenance. If you have less stones and sand and dirt in the boilers, there is less wear and tear.
A key challenge, researchers say, was how to calibrate wood chips so that the analyzer provides accurate, reliable data. The system is based on X-ray beams that can identify materials like sand or stones with higher densities than wood.
Wood residue can be very complex. It can be anything that looks from ordinary wood chips almost to dirt. And to calibrate this is kind of complicated because you have to calibrate for a lot of different types of essentially materials. And in this lab, this lab enables us to get our own samples and to do this calibration.
The next step, researchers say, is to install such analyzers on conveyor belts for faster checking of larger volumes of biomass. Lower operational costs could translate into cheaper energy prices, according to managers at this power plant.
Vi har kalkylerat och räknat ut att vi kan spara 100 till 150.
The analyzer could help us save between 100,000 and 150,000 euros per year, as we'd be able to produce more energy and reduce our maintenance work.
Verkningsgrad på pannorna och klart minskade underhållskostnader.
Developers say the same analyzing technology could be applied to other raw materials being used as biomass around the world, like rice husks or cereal straws.